Hello friends, in this video we are going to work out a few problems asked in the past in some competitive exams like CSIR, GATE and PGTRB. In the previous videos we have studied a detailed theory on isomerism and coordination compounds, square planar complexes, tetrahedral complexes, octahedral complexes, of course the structural isomerism. We had a detailed study in the past. So in this video we are going to solve some problems asked in the old question papers. Okay, let's begin with this. The first question, it was asked in 2014 CSIR. The number of stereoisomers of triethylene tetramine dichlorocobalt 3 bromide. There are 4 options. Okay, the number of stereoisomers in trans isomer. Could you identify what is this isomer? Okay, triethylene tetramine. Okay, this is ethylene diamine. Triethylene tetramine means there's one more ethylene diamine and there is another ethylene diamine. So 3 ethylene diamines are fused together. So that means 1, 2, 3, 4 nitrogens. Okay, N connected by N, connected by another N, and connected by one more N. Okay, so it is a tetradentate ligand. Okay, so the complex is trans, triethylene tetramine dichlorocomplex. Okay, that means cobalt, since it is specifically mentioned as trans, so let me put 2 chlorine at the trans position. So we have 4 nitrogens, N, 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 N. Okay, okay, so what is this? Is it optically active or not? Is it optically active or not? This complex is, hope you remember, in the octahedral complexes, when we have same monodentate ligands at the axial position, that is optically inactive. It consists of plane of symmetry. So here we have 2 same ligands, chlorine, okay, and they are specifically mentioned as it is trans. There should be another isomer, that is cis isomer, but they have specifically given trans isomer. So trans isomer means this is optically inactive. Okay, so that means only one isomer. It has no optical isomer, and we can't speak about cis isomer because they are specifically given trans. So this trans isomer is optically inactive. So only one isomer, only one stereoisomer. So the answer is 1. Okay, and let's see the next question. Among the following complexes, okay, there are 3 complexes given. Out of these 3, the chiral one is, okay, our chiral ones are, okay. Look at this first complex. It is dioxylato cobalt 3 complex. Oxalate means it is a symmetrical bidentate ligand. Okay, this is oxalate. This is oxalate. That means oxygen, oxygen. So it is a symmetrical bidentate ligand. Okay, symmetrical bidentate ligand. So they have mentioned dioxylate cobalt. So that means cobalt, okay, dioxylate cobalt 3 minus. Look at this. Is it optically active or not? It's a square planar complex. I already told you that square planar complexes are optically inactive because they are superimposable with their mirror images. So this complex, okay, is optically inactive. This is square planar complex, optically inactive. So A is not the answer. And let's see B. Trans um, bis ethylene diamine dichlorocobalt 3. Okay, look at this. What what type this complex belongs to? Okay, COCl2. Ethylene diamine means it is a symmetrical bidentate ligand, so it is AA type. So AA twice, B2 metal. That means metal. Let's see. Yeah, means metal AA twice, B2 type. Okay. AA twice represents the 2 ethylene diamine. B2 represents the 2 chlorine, 2 chlorines. So we have already seen that this has cis and trans, but out of that, trans is optically inactive. Chlorine, chlorine, AA. See, this is trans, this is optically inactive, but cis one is optically active. Cl, Cl, A, A. So trans is optically active. Okay, Cl means Bb. So okay, Cl means Bb. Okay, so cis is optically active, trans is optically inactive. The question is what? The chiral one. Okay, that means they have asked, they have given what? Trans isomer, not cis. They didn't give the cis isomer, they have given trans. Trans is optically inactive. We have already studied. So B is also uh, not the answer. And see this one, an EDTA complex. EDTA complex means it is a hexadentate ligand. Okay, EDTA complexes are optically active. We have already seen a metal. EDTA means what? Ethylene diamine tetraacetic acid. There will be 2 nitrogens and 4 oxygens. This one is optically active, this one, and it will have its mirror image. Okay, so if it is D means you will have L. Okay, this one this is EDTA complex. Okay, this is EDTA complex. EDTA complex is optically active. Okay, so your answer is C only. Okay, the first one is optically inactive because the square planar complex. This one is octahedral complex but trans isomer, optically inactive. And the final one is EDTA complex, hexadentate ligand, and that is optically active. So answer is C. Okay, let's see the next one. The complex which can exhibit facial and meridional isomer. Okay, they have given, you hope you remember, facial meridional means what? M A3 B3 type. Okay, A3 B3 means A and B are monodentate ligands. Okay. Do we have any complex like this? Look at this first one. Let's try all these complexes. Okay, triglycinato cobalt 3. Okay, cobalt triglycinato. Glycinato means oxygen and nitrogen. Okay, this is one, oxygen, nitrogen. Another one, oxygen, nitrogen. Another one. Okay, this is first one, A. And B is what? Tris ethylene diamine cobalt 3. Cobalt ethylene diamine. Ethylene diamine means it is a symmetric bidentate ligand. And what is C? Dichloro diglycinato cobalt 3. That means cobalt dichloro diglycinato. Glycinato means nitrogen and oxygen. Okay, unsymmetrical bidentate ligands. Okay. This is C. And D is what? Trioxalato cobaltate 3. Oxalato means what? That is it is a symmetric bidentate ligand. We have seen in the previous problem. So D is cobalt Oxygen, 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 oxygen. Trioxylato. Okay. Look at these four complexes. Where do we have A3B3 type? You look at this. All the three, okay, nitrogen, 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 okay. Everywhere six nitrogens are surrounded by a metal. So you can't have three A3B3 type. But you look at this, two chlorine, two nitrogen, two oxygen. Okay. That means this is not A2B2 type. If I assume that chlorine as A means A2, nitrogen as B means B2, oxygen as C means C2. So A2, B2, C2. That way we can say. But look at this one. Everywhere 6 oxygen, just like the glycine, just like ethylene diamine. So this one no, this one also no. Okay. These two are, you can't get facial isomer Ma3B3 type, you can't get in these three. Of course, here also you won't get. But look at this one. 3 nitrogen, 3 oxygen. Okay, this looks like Ma3B3. 3 nitrogen, 3 oxygen. Look at this complex. How does it look like? These 3 oxygens, okay, these 3 oxygens are in the square. That means they are at the meridian. So this is a meridional isomer. This is a meridional isomer. If I draw the facial isomer of this, cobalt, nitrogen, nitrogen, oxygen, oxygen, nitrogen, oxygen. Look at this. So these three oxygens are in one phase of the octahedron. Okay, and these 3 nitrogens are in one phase of the octahedron. That means this is facial isomer, this one is meridional isomer. So option A can exhibit the facial and meridional isomers. So answer is A. And let's take this one. The number of possible isomers of ruthenium, ACAC triphenylphosphine, bis diphenylphosphine complexes, bis triphenylphosphine complex. Look at this complex. How does it look like? ACAC means acetyl acetonato ligand. Okay, this is acetyl acetone. This is acetyl acetone. Acetyl acetonato means this one. Okay, oxygen. It is like this. Here negative charge. Okay, this is ACAC, acetyl acetonato ligand. So this one is a symmetrical bidentate ligand because you have 2 oxygen. Okay, so 2 oxygen, symmetric bidentate ligand. So look at this complex here. So you have a symmetric bidentate ligand, that means AA type. Okay, that means AA type, M AA twice. Here triphenylphosphine 2, that means B2. MAA twice, B2 type. Okay, the number of possible isomers. Hope you have studied in MAA twice, B2. How many complex? How many isomers? We have one cis and the other one is trans. M AA B B. This is trans isomer and this is optically inactive. And we'll have cis isomer BB. Cis isomer, this is optically active. That means total isomers, this is optically inactive, this is optically active. So optically inactive isomer 1, optically active isomer means this one plus its mirror image. Okay, if it is D and you'll have L. Okay, so This is 1 and here this is 2. Optically inactive isomer 1, optically active isomers 2, so total 3. Okay, this we have already seen, so answer is B. And let's take this one. Identify the chiral complexes from the following. Look at this. The first one is EDTA complex. Okay, we have already seen EDTA complexes optically active. Okay, so this one is they identify the chiral complexes from the following. EDTA complexes optically active, we know. And ruthenium, this one is bipyridyl complex. Okay, ruthenium bipyridyl. Bipyridine means this one. This is pyridine N, and this one is bipyridine. Bipyridyl complex. This is a symmetric bidentate ligand which is equal to N. So that means AA type. Okay, this is a AA type, symmetric bidentate ligand. So how about this one? Ruthenium bipyridyl means ruthenium. That means metal AA thrice. Metal AA thrice. Is it optically active or not? Of course it is optically active. We already studied. It is optically active because M A. Okay, this is optically active. I have already told you, when a bidentate ligand is there, when a bidentate ligand is connecting an equatorial position and an axial position, the complex is going to be optically active. We have already seen in the previous video. Here there is a bidentate ligand, 3 bidentate ligands, no matter it is symmetric or unsymmetric, but here it is symmetric. Okay, so this ligand occupies 2 equatorial position, so that is not important for us. But see here, it is connecting an axial and equatorial, and that is optically active. We have seen in the previous video. So this one is also optically active. So ruthenium bipyridyl complex, that is also optically active. Look at the third one, platinum. What is it? Di-N. Di-N means what? N represents ethylene diamine. Di-N means diethylene diamine. Okay, Di-N means diethylene diamine. That means this is ethylene diamine. This is another ethylene diamine. That means here no nitrogen. So N. So it's a tridentate ligand. So in this complex, if we draw like this, okay, so platinum N. This is tri-N. What is remaining? Chlorine. Okay, chlorine. How about this complex? Is it optically active or not? Okay, it's a square planar complex. I already told you that square planar complexes are superimposable with their mirror images, so they are optically inactive. Square planar complexes are optically inactive, so the answer is A and B. Where is A and B? This one. Okay, A and B are optically active complexes, chiral complexes. Okay, let's see this one. Identify the chiral complexes from the following. Okay. Oh. Okay. Identify the chiral complexes from the following. I think the same question is repeating. Okay, it's a typographic. Please leave it. And let's see the next one. Okay, let's see this question as from PGTRB. Able to read it? Which one of the following complexes can exist as D and L isomer? Able to see this? Okay. Which one of the following complexes can exist as D and L isomers? So here are complexes given. Okay. Maybe let me slightly zoom it. Visible? Yes. The first one is, look at the first one. What is the first one? Cobalt tetramine dichloro. Okay, tetramine dichlorocobalt 3. The complex A is, what is this type? Metal, cobalt. A4, that is tetramine. B2, that is dichloro. And complex B, cobalt, I mean metal. This is A3, triamine means A3, trichloro, B3. And complex C, trans cobalt diethylene, okay, metal. Ethylene diamine means AA type twice, and Cl2, that is B2 type. This is trans. And D is cis, same complex but cis one, cis M AA2 B2. Look at them. We have already seen A4B2 type is optically inactive. It has only geometrical isomers, cis and trans. And MA3B3 means what? It is facial meridional isomers. There's also optically, they are also optically inactive. Only facial and meridional, two geometrical isomers. Look at this one, trans isomer. MAA2B2 type we already discussed. This is also optically inactive, but cis isomer is optically active. So out of these four, answer is D. D is the answer. Okay. Hope you understand. If you have any queries and comments, please write it in the comment box, and we'll meet in the next video with some other interesting topics. Wish you all the best. Thank you very much.